Hi everybody. Today I'm going to be walking you through OneLogin's API training. The goals of this training are to teach you the fundamentals of how keys and OAuth work in order to access various API endpoints. I'll be talking about the fundamentals of APIs. I'll also be doing some specific deep dives into our Events API and Users API. And then finally I'll walk you through our authorization and authentication APIs as well. First and foremost, all of OneLogin's APIs are RESTful, web-based APIs. This means all of these APIs are called via HTTP. In HTTP, there are 4 verbs that we make use of. They are get, this retrieves information about specific resources. In this case, you just saw one when I loaded this web page. A post operation. This sends new information to the specific source and is essentially the same as what happens when you fill out a form on a web page and hit submit. There are then the verbs for put, rather than a post, updates existing information, and finally there's a delete. This removes existing information. Every HTTP request is made up of 3 parts. There's the request line. This tells the server what kind of request is being sent, whether it's a GET, a POST, or whatever, and what resource it's looking for. The header, which sends the server additional information, such as what client is making the request. Finally, there's the body, which can be empty, such as when you get or delete something, or it can contain data, if you're either posting new data or putting updated information. And finally, there's a response. The response is what the server returns about the status of the request you made. And generally, this is either going to be a succeed or a fail. So first things first, let's talk about keys and OAuth. We'll diagram the basic flow of how to grant access to make API calls. We'll review how to revoke tokens. We'll discuss best practices for managing keys or access to keys. And finally, we'll show how to read, write, update, and delete these keys. The client ID and client secret key are fundamentally what we talk about when we refer to an API key. This is a set of credentials that are analogous to a username and password for logging into a web service. All of these keys, when they're generated within OneLogin, are assigned a set of permissions. These permissions come in 4 forms. The ability to read users. This limits the ability to do anything other than read user data, and allows you to perform GET calls for the user role and group API resources, as well as the Events API. Manage users is equivalent to read-write access to the same resources. The one exception to this is the setting of passwords or assigning and removing roles. These are viewed as things that only an admin should be able to do. There's also read-all permission. This gives the credential pair the ability to generate an access token that can perform GET calls for all available API resources. And finally, there's the manage-all permission. This gives the credential pair the ability to generate an access token that can perform all of the API calls available. One thing to note is the manage-all permission is equivalent to super user access. So all of these credentials should be kept secure and take care not to inadvertently embed them in any shared code. As an example of this, there are people out there who have written bots that scan all of GitHub looking for engineers who inadvertently have added API keys into their code. They then grab these keys and immediately use them for nefarious purposes. So again, keep these credentials secure and take care not to inadvertently embed them in code that's shared with others. So creating the client secret and client ID. Only 2 users within OneLogin have permission to create a client ID and client secret. That's either a super user or the account owner. Now, client ID and client secret do not actually allow you access to the various API endpoints. Whenever you access an endpoint, this requires an access token. This is part of the OAuth 2 spec. Access tokens essentially are credentials used to access the actual resources on the APIs. It comes in a string format and it represents authorization issued to the client. The phrase, "the string is usually opaque to the client," means essentially this. The string can come in many formats and we reserve the right to change it at any time. The string must be handed off to the API endpoints in the same way that it was handed off to you when you requested an access token. So the basic idea here is you use the client ID and client secret to generate an access token. That access token then allows you to reach and talk to the various API endpoints. This is very analogous to what happens when you log into any web service. You provide a username and password. Once you've given the web service a username and password, it returns a session token to you. This session token is almost always in the form of a cookie that's set on your browser. The presence of this cookie on your browser then allows you access to that web service for a period of however long the session is set to in that particular application. And an access token is very much analogous to this. You provide the client ID and client secret, and in return you're granted an access token, which is good for no more than 10 hours. You can make no more than 5,000 calls per hour with any given access token. And the rate limit of 5,000 calls per hour is refreshed after each hour. Now, the format of what's returned when you provide a client ID and client secret is you will get an access token. You will also get details about when this was created, when it expires. You also get what's called a refresh token, and I'll talk more about that later. And then finally, you'll get a token type and an account ID, both of which aren't really of interest to you. They're just there to make sure we fully adhere to the OAuth 2 spec. So generating an access token, how do you do this? Well, as I said before, you provide a client ID and a client secret. If those are valid, it'll return an access token and a refresh token. Of course, if they're invalid, it'll return an error message. And this is done through the OAuth 2 flow, using what's called a grant type of client credentials to get an access and refresh token. And you can do this through a variety of ways. Some folks choose to do it manually, where they simply go into a tool like Postman or curl. Other folks write code to do this, and there are OAuth 2 libraries available for every major computer programming language. Now, before I mention an access token, there's also what's called a refresh token. A refresh token, unlike an access token, is valid for up to 45 days after it's been generated. If you haven't made any calls, however, within those 45 days, then a new set of tokens must be generated using the client ID and secret. Now, what is a refresh token? A refresh token is a way to obtain a new access and refresh token. Refresh tokens are issued to the client by the authorization server and are used to obtain a new access token when the current access token becomes invalid or expires. One way to think of the pattern for using refresh tokens is this. When you get an access token, you can use it for a period of up to 10 hours. But before that access token expires, you may want to refresh it. So in this case, you can hand off the refresh token and exchange that for a new access and new refresh token. And the idea here really is to limit the amount of time the number of times you pass that client ID and client secret over. It's far better to hand off an access token and a refresh token. This way, you're not essentially giving away the equivalent of a username and password. Instead, you're exchanging a small bit of information that is only valid for a short period of time. And one thing to note, when you refresh that token, that will revoke access to the older tokens. And finally, there's a revoking tokens call. A revoke token call is used to simply get rid of the access and refresh token and make them invalid. And in this case, not generate a new access token and a new refresh token. Revoke tokens is not typically used because the act of refreshing and generating a new token will automatically revoke the old one. Revoke tokens is more or less used if you're accessing extremely sensitive information and you're done and you don't wish to access that information anymore. By revoking the token, you can make sure that if for whatever reason one of your access tokens leaked out and someone got a hold of it, by revoking that token, you effectively invalidate it. So regardless of whether someone else has access to that token or not, they can no longer use it. Again, revoking tokens looks very similar to the other calls, both the generate token and the refresh token. Once again, you make an API call, you pass in either a client ID or client secret, or you can pass in your old access token. Now let's talk about what are some of the implications of all of this. Once you generate a client ID and secret, which we'll call an API key from now on, it should really only be used by a single client or process, since whenever it's used to generate an access token, all the other access tokens generated by that key will be invalidated. Now, if multiple clients or threads within a single process need to use the same credentials, they'll need to cooperate when it's time to refresh an access token. Again, the act of refreshing the access token will invalidate the old one. And also, it's generally more secure to give clients the access token and refresh token rather than the key. This way, it's far more difficult to hijack the credentials since calls will only be using the access token and it has a very short life. Also, if someone does grab the refresh token or the key and uses it, it will be immediately apparent, since the access token will stop working and the client will be unable to refresh their token, since the malicious use of the token will invalidate theirs. So, one API key per client or process is just good practice. So let's talk a little bit about some of the implications of the flow when it comes time to refresh an access token. In this example, I've got 3 separate threads that are all sharing an access token, and they're using that to make various API calls. Now, when it comes time to refresh that access token, it's best to momentarily stop these threads and have them wait for a moment. Then an independent thread would go in, refresh that access token, update it at a central location, and then you'd allow the threads to start using that access token again. And most people follow this pattern, where they'll set something up that when they get themselves an access token, they look at when it's set to expire, and then set up a thread that sleeps for, say, 15 minutes less than the expiration time of that particular access token, and when the timer goes off, it simply goes in and generates a new one. Once an admin has a client ID and client secret, they can simply use curl or postman to generate an access and refresh token. Those can then be given to the developer or the process through a secure method, such as encrypted email, secure notes, etc. Remember, these are almost as valuable as a username and password, so it's best that you treat them as such. Don't hand them off on Post-it notes. Far better to send them through a secure channel. Now let's talk a little bit about what happens if an access token does get stolen by someone. Again, previous example, you have a number of threads that are all sharing an access token and using it. But then a rogue client comes along and grabs your access token and your refresh token and says, great, I'm going to use these to generate my own access token and my own refresh token. I'm effectively going to hijack this and take control of it. Well, a few things happen. One, that access token ceases to work once a new one has been generated. This will then become immediately apparent. So an admin at this point can simply use the client ID and client secret to generate a new access token. At that point, the rogue client is locked out. Why? Because their access token has been invalidated by the act of creating a new one using the client ID and client secret. And again, the refresher can come back in and begin updating that access token again. The basic idea behind all of these flows is to limit the number of times you're actually transmitting the client ID and client secret to as few as possible, and instead relying on the access and refresh tokens to generate new access and refresh tokens. This effectively keeps the keys to the kingdom as secret as possible. Now, all of this may seem a bit paranoid, but unfortunately there are instances when HTTPS communications have become exposed through things like bugs in routers and other network infrastructure. So while rare, it does happen sometimes that even secured HTTPS communications can leak out into the wild. So again, by keeping the use of the client ID and client secret to a minimum, instead relying on the access and refresh tokens, the type of information that's leaked is less valuable to a hacker. These access tokens are short-lived, and even the refresh token has a limited lifespan. So in this case, I'm going to take a look at some sample code we've got up on GitHub. So now we're going to walk through some sample code written in PHP that'll walk you through some of the fundamentals of generating tokens, refreshing tokens, and expiring tokens. All of these rely on the curl library. And there are similar examples of this for other languages if you go to our developer site. So first and foremost, you set the URL that you want to call, in this case api.us or EU onelogin.com/auth OAuth2/token. And you'll see this endpoint used throughout this example code. Here you see the client ID and client secret are provided. Now, unlike this code, I would not actually embed these in my code, but instead I would have some code here to retrieve these from a secure location. Next up, we're setting up the data we want to transmit, and in this case, it's the set of client credentials is what we're asking for. This is then encoded into JSON, as all our endpoints rely on JSON for both input and output, and then the authorization header is set with the client ID and the client secret. From there, we initialize the curl call. We set options to the type, which in this case will always be post. We pass in the data that we set up before, that was encoded as JSON. We set up various headers, set header options, which will always be type application JSON. We set up our authorization header, and of course, set the content length for these headers. Once all that's set, we simply execute the curl command, and this will actually perform the operation of reaching out to the OneLogin servers and returning a result. If a result is returned, and it always should be, we fetch certain details about the callback. First and foremost, we grab the body of the message, and we take that data and we decode it from JSON. Again, all the input types are going to be JSON, and all the return types will be JSON as well. So first thing, we check to make sure there is no error message. If there is, however, we extract the status code, the status type, and the error message from the return values. And in this case, this code throws an exception with details in the error message. Otherwise, we pull back the various bits of data that are returned in the JSON body. In this case, we'll always look for an access token, a date the token was created at, very important piece of information when this particular access token expires, as well as a refresh token and a token type and account ID. You don't really need to look at the token type and account ID because in every instance of this call, the data type will be bearer token. And that's basically it. Now for refresh tokens, you'll notice this code looks very similar. Again, same endpoint. The client ID and client secret are in here, but they're not actually used. Ultimately, the data that's passed across is basically the grant type, which in this case is refresh token, the access token, and the refresh token. Hopefully you can remember from the previous section where we talked about how you can use a client ID and client secret to generate an access token, But you can also use an access token and a refresh token in order to generate a new one. So we go through the same code we did before, and finally execute the actual request to our servers. And once again, this looks very familiar. We basically either look for an error message from the JSON decoded body, and if no error message, we'll see an access token, a refresh token, and details about when the token expires. Now this call uses a slightly different endpoint. This one uses the OAuth2/revoke endpoint. But similarly, it takes the same details as the previous calls do, packages them up, and executes them. Now in this case, we don't actually return any details in this call. This call simply revokes the token. So the only piece of data to look at is the status code. And then finally, we have a little utility here. This basically just takes an access token, packages it up as a bearer token. This is a simple GET request that's packaged up into a curl object. We then execute the curl. And again, we either look for an error message and throw an exception, or we pull various bits of data out of the response. In this case, the only pieces of data returned are what's the rate limit? In other words, how many calls have I made in the last hour? How many calls are remaining? Am I allowed to make? How much longer is it until the rate limit is reset? And in this case, it includes a little bit of functionality to simply output to the command line a little bit of details about how much time is left. And that's all. So now we're going to go back and talk a little bit about how to actually use these APIs to get events from OneLogin.